So yeah, this is intro to Godot. I'll give you a couple more seconds to do the QR code. Just raise your hand. How many people have taken a object-oriented programming or just intro to programming class? All right, so most people here. All right, so I made this slideshow assuming everyone in here had taken those classes, so that's good. All right. So just a brief overview of what we're going to talk about today. We're going to talk about just an overview of Godot. Then we're going to talk about the editor. I'm going to take you into just a blank project and show you around the various items in the editor. Then we'll talk about nodes and scenes and how they interact with one another and what they are. Then we'll be talking about GDSC, the unique programming language used in Godot. And then we'll be talking about signals, basically just a way to communicate between nodes. So here's a few facts about Godot. It's open source, meaning it's completely free. There will be, no matter how many copies of your game you'll sell, you never have to pay a single cent to the Godot Foundation because it uses the MIT license, a very liberal and open kind of license for its software. It creates 2D and 3D games. It used to only create 2D games, and it also creates cross-platform games. It'll create Mac, iOS, AR, VR, Windows, whatever, Android. I'm trying to think what else I haven't mentioned. Linux also does that, and web builds. It has a built-in script editor, unlike Unity, which has a whole you need a different application for its script editor. As long as you're using GDSC, you can just use scripting in one single window. Uses on custom-built script, which I'll get to later. It has editor plugins with its asset. It's called an asset library, but I've very rarely used it for assets. I usually just use it for things like card template things, just to quickly prototype things. It's also a very lightweight editor. I think the program comes in at about 3 gigabytes. In comparison, Unity is about 10 or 12, so pretty lightweight. So if you have a weaker machine, then you don't need to worry about how well this runs. And then this is a quote directly from the Godot overview. It also touches on a lot of the subjects that I'm talking about. In Godot, a game is a tree of nodes that you group together into scenes. You can then wire these nodes together to communicate using signals. So just a good way of thinking about how Godot functions. Here are a few games made in Godot. There aren't a whole lot of them, unlike Unity and Unreal. This is to most people, a very new game engine. It only really came into limelight in 2023 with the whole Unity pricing thing, which is mostly in the past now. So, but yeah, we have Buckshot Roulette, Brotato, and Backpack Battles are the 3 big ones on Steam right now. So let's hop into the editor just to give you a brief overview of what it looks like. So over here, starting in the top left, these 5 buttons. The scene button is just a quick way to just see all the various options of the scene. There are other ways of creating new scenes, such as just hitting this plus button here, or right-clicking down here, and you can pick a new scene. I don't use this section a whole lot, except for maybe export as, quick open if I'm loading a scene from a different project that I want to pull in that's reusable. Project, this is a very useful one. Project settings is a page you'll really want to get familiar with. It says everything from general, just how your game is rendering, from input maps all the way to global accessible variables and scripts, and plugins that you'll be using. So we'll start with, these are all just mostly, you don't really need to know all these things. It looks like a lot. About 10% of these are things you're ever going to touch, unless you have a good reason to touch them. The main one I've ever touched is under rendering textures. If I'm doing pixel art games, I go to nearest instead of linear, so it doesn't look as blurry. That's the main setting I always tweak. And then input map is just a way to map different controls and different control options onto a single action in a game. So let's say I want to do move left as an action. I can have that sync to. I can create a new action doing that by just typing in add new action and then pressing enter. And then once I hit that plus, it will start listening to all the buttons I'm hitting on my keyboard. I can have it listen to A and then hit OK. And I can also have it listen to the left arrow if I don't delete it on accident. And then also this works with all controllers as well. So it's very easy to hook up controllers. It's not like some other game engines where you have to individually remap controls based on the controller that is like the active one. So that's really nice. So you can just set this all up beforehand once you're making your project and never have to touch it again. And then globals, this is another one I use a lot. Something called auto load is something I do a lot. So let's say I create a, oh wait, I need to close out of this. I'm going to create a, actually, I'll cover this later because I do cover auto-loaded scripts later. But just know that auto-loaded scripts are basically scripts that are run as soon as the game starts, and all the variables and things are fully globally accessible under the name of that script. So, project settings, and then plugins. So, for instance, like my card game plugin or something else that I'll use, you'll just sync that up there. It also, a lot of plugins add like new nodes to Godot that just have very specific functionality but are kind of useful. Like a first-person shooter character node is a pretty common one that a lot of people add that's not in Godot. So, all right, but moving down a little bit, we're going to move into this. This is what's called the scene tree. Every single scene will have a different view here. So if I add a new one, I can make a user interface scene. We'll call this main menu, something like that. And then this can just be, I don't know, player. The scene tree is basically just a way of accessing every single node in a scene, and then quickly dragging and dropping other scenes into it. So, for instance, if you're making like a level, you don't want to create a new like player every single time. You can just drag a scene in and plug it in to the level. Well, if you're confused on these terms, I'll go over them in a bit. Sorry that it's a bit out of order. It's kind of hard to introduce like a whole application all at once, but. Here and down here is just the file system. All the files in your project will be available here. By default, you'll just have this Godot icon. I use this a lot for debugging for like a player character or something. And then we also have over here is the inspector. This is where you can change all the variables to do with an object, like its offset, whether it's vertically flipped or horizontally flipped, something like that. And then depending on if you're making a 2D or 3D game, it literally just means are you adding nodes into here or are you adding nodes into there? That's really the only difference between 2D and 3D in Godot. And then script, this is all the built-in script editor stuff. So if I add a script here, you can see all the code I write will be in there. And then game, this is pretty new. It's a little buggy, but this is basically a built-in window for playing your game. When you press play, usually it'll just pop out a brand new window to play your game, and that's usually what I'm used to. If you're coming in from Unity, this will be very similar to the way Unity does it, where you can edit properties and values like as the game is running. So, and then asset library, I'm not online right now, but this is where you could like search for first-person controller, and then it will show you just basic. This is one I recommend for anyone doing first-person stuff. You can just quickly drag and drop that scene into your game and then just get a first-person controller up and running real fast. But anyway, back to, oh yeah, there's this, this is just the play button, just so you know. You can also just hit F5 and then just stop. It'll ask you what scene you want to run, but F5 and then F8 is to stop. But let's head back to the actual concepts. All right, nodes. Godot has roughly 220 nodes, so I cannot do even a very small portion of that today. For the most part, nodes are pretty self-explanatory. Things like camera, timer, player. A good way of quickly understanding what a node does is that when you go into the scene hierarchy, well, not scene hierarchy, but this hierarchy, all of these things inherit from node, which has the just very basic properties like what it does during process, and then. So if it's below the item in the dropdown, it will have all of the properties of everything above it in the hierarchy. So everything will have the properties of node. Everything in node TD will have the properties of like position, rotation. Everything in, I believe it is character body will have, well, there's only one thing, but any collision shape object will require a collision shape to be created. And yeah, there's a lot. As you can see, this is like not even half of them, but yeah, just focus on a few at a time. Some games can be made entirely with just 2 or 3 nodes. Tetris is a good example. You only really need one node to make Tetris, and that's the tile map layer. I will just touch on the fact that some of these will have a red X next to them. Do not use these nodes because if even 1 or 2 updates down the line, it will probably be just deleted from Godot because there's probably a replacement node that's just better in almost every single way. And then some of the nodes, if I can find them, yeah, like these are experimental. You can use them, but they're likely to change. So some methods might break during an update. We just had an update for 4.5, so if you're just dumping into Godot now, you shouldn't have many game-breaking updates for a while. So, yeah, the three major categories are 2D, 3D, and control. 2D is any 2D game object, 3D is any 3D game object, control is menus, UI, anything like that. And then there are some nodes like timer that work for all three. All they have is just a simple number that tells you how much time you have left. And then scenes, these are just empty containers that just hold nodes in a certain structure. The order of your nodes in the scene does matter a little bit. So for instance, this game, this example scene here, camera 2D being at the top doesn't really matter. The court being at the top does matter because it will render behind everything. So the higher up it is, if it has a rendering thing like a sprite or an animated sprite, it will render behind everything. So then ball, player, and enemy will all render in front of the background. If I moved court down to the bottom, it would render in front of everything and block it. And then, so this is another game that can be made all in one scene. Ball, this is just area 2D with a collision shape and a sprite. It just means it takes up some area, has a collision shape, and is visible. And then audio stream player, which is just it can play audio towards into your speakers. That's it. Yeah, any discrete part of your game, so player, like for instance, if I were to remake this little project over here, I'd probably have ball as its own scene, and then player and enemy as probably just inherit from something called like paddle or something that can just move around, and then I'll just have enemy like make AI, and the other one will just respond to player inputs. So, but anyway, that's just personal preference. But change this one. Yeah, you can change between scenes. Some people, there are some creators who really hate the fact when you change between scenes, some data is lost. But I mean, if you have a main script and you don't save the variable somewhere, that data will be lost once you re-enter the scene. So you do have to like save things like that. But there are ways of making data persistent. They'll advocate for having a root node basically, and then just swapping out the level underneath that and keeping all the data in the root node so it never changes. So if you ever watch a Godot tutorial and they argue against changing scenes, it has its pluses and minuses. It just depends on what you're doing. For very simple games, you really never need to like do that with where you have like a root node because it's just kind of unnecessary unless you're making a very large game where you have a lot of data and it'd be just too much to save. But anyway, yeah, you can load scenes from files. I didn't like save any of the scenes that I made, but it would just appear in the file explorer down here, and then you can just drag and drop it either into here or into like somewhere over here where it might accept like a packed scene where it can like then be loaded later. So now we're going to move on to the dedicated scripting language of Godot, called GDSC. They originally used Lua, and then they realized this isn't the best for object-oriented programming, heavy things like game development. So then they briefly switched to Python. They like tried it out, and they're like, this isn't really for us. So for the exact specifications they wanted to fulfill, they just made their own script based on built off of C++, but it looks nothing like C++. It looks a lot more like Python. Their goals were that they wanted to be highly flexible. They wanted it to be very lightweight, so that's why it's built off of C++. But they also wanted to be very readable, so it looks nothing like C++, looks like Python. But they also wanted to be object-oriented focused. So Lua was kind of out of the realm of possibility because Lua has a very odd way of doing object-oriented programming. So it's dynamically typed, but it has static typing options, and I do recommend using static typing wherever possible, just because it helps with debugging, because Godot can warn you about errors ahead of time if you're misusing a function or reassigning a value to some variable you're not meaning to. And then, yeah, built off C++. If you're used to C#, if you're coming from Unity, you can use C#. You have to download the .NET version of Godot, which integrates more with C#, and then you also need an external editor. And then anywhere 8.0 and up with .NET. I think it's out 23 right now, so anywhere you're getting .NET should work just fine. So these are a lot of terms used in GDSC. I'm not going to go, this isn't all of them. A lot of them like if, else, else if, for, while, those look and work exactly like Python does. So extends, that just means every single script you'll ever write needs to have extends. Even if it's just extends an object, it still needs to have it somewhere in it. Class name, this creates a new class that extends. I need to. It extends the class. Sorry, I lost my train of thought. Here's done. So if you're creating custom nodes, so one I do a lot is a level exit node, where if it detects something like player walking into it, then it will switch to some like packed scene of the next level. I use this a lot in a lot of games. That's usually the one I port over between games. And I make a whole new class name for it just so that I can like easily detect if an object is like entering is a player and it's not just a player object. Because sometimes I'll use a player object for enemies and not just the player character. Class creates an inner class. It is not a class available to all scripts. It's just to any scripts that extend the code that you have written or that specific class. So I don't use that very often. I haven't seen it used that often. It's usually used if you're making a game that's just one single like script object like Tetris or something. You want to make a class for pieces or something. Var, create a variable, just an object, a data type of type variable, which can be assigned to integer, float, string, vector to any of these other data types. Const creates a constant, cannot be edited and cannot be equal to a function. Enum creates an enum. I usually only use enums if I'm having in the editor. Sometimes you'll see, I don't know if I can find one real fast. Okay, here. So this is an enum. You can just quickly pick between these, and we'll get to how to like add these for your own like, custom project. I don't know how big that is. I should have probably recessed it before. I'm sorry about that. That's really the only time I've ever used enum that often. But if you want to use enum and use it more than I do, then you can do it. Func creates a new function. Works the exact same way as def does in Python. I was a Python developer, so that's why I use Godot instead of like Unity. So I'm kind of used to it. Super, it accesses the extended class. So if you want to call a specific function, you can just do that. And everything else is the same as Python. These are somewhat odd. They're not, the way they work is very unique for all of them. Abstract makes an abstract class. You just put it at the very top of your file. Some of these do need to be at the very top. Icon needs to be before everything else in your file, otherwise it will just not work and you can't run the game. Tool also needs to be at the top, and then all of these are fine being basically anywhere, as long as they're not exporting a variable that you're going to use somewhere later in the file, or somewhere earlier in the file. So just put it somewhere near the top. So the three main types of exports. There are way too many types of exports. There's like export color, export enum, and I'm not going to go through all of them. There will be a brief example on the next slide, but export is just makes a variable available to the editor. So like over here, there's an export variable for a vector, and then it just is, I can edit the x value, or I can edit the y value, something like that. Export category, that is the little, like these header things up here. They're usually used for when you're making a whole new class, so they'll be used with class name a lot. And then export group, that is the like drop-down menu, like this visibility one, just a group of variables. So if you're ever making something like these where you're going to be sharing them a lot, just having better, like, I cannot think of the word. It's just easier to use if you organize them instead of just having a long list. So. And then onReady, this is usually only used for if you're setting a variable equal to a node. So let's say you're making an enemy character and you want that enemy to be able to know exactly the position of the player character. You could have it do like onReady, get like this file for the player character or something like that. Or export a value that's like node 2D, and then the player character, you can just drag and drop its scene into that. So here's an example. So You see exports category, test int, and then it goes all the way down, entities. You can export colors, you can export, when you export a node, we'll say a sign here, and when you click on that, it will show you its current scene tree, and it will list any nodes that are available under that type. So if I had like a control node, it wouldn't be visible if I clicked the sign. If I had like something like a player character body 2D, then it would be visible once I had a sign. Group, it has a little drop down menu, and then there's also subgroup if you want to get really in depth with things. There's various strings, what happens when you export them, range, you get a slider bar. Yes, that is it. Those are the main ones. There are a lot more. There's also like custom exports, but I never mess with those. Those are only for making like very specific tools and like that are going to be used a lot. So now we're going to go on to signals. So we made nodes, we made scenes, we have all these objects, but how do they actually like talk to each other? This is how you do them in Godot. You don't want objects having to get direct references to one another, because imagine if you're trying to simulate traffic. You don't want the traffic light to have to get access to every single car that is looking at that traffic light to be able to turn green and tell it to go. Instead, you could have the traffic light set up so that you could just have a signal called turn green, and then have all the cars connect to it and say on turn green, and then execute some function like just drive forward or accelerate or something like that. The exact way in which you connect them is very hotly debated. Generally, the one I use is either if you're adding a like enemy, so let's say you're making a chess game and you create a new enemy and you want to connect it to like a manager of all of your enemies. Once you add the child, you have to instantiate it, and in between when you instantiate it and when you add it to the actual scene, I usually connect it to the signal there. Or what you can do with auto load, which I do this a lot, probably a lot more than I should, but you can create a script down here, project, and then project settings. It's really hard to see because it's small in here. Globals, you can pick a, why did it take me there? Godot, where is it? There we go. Pick that script, and then node name, then add. And now I can add all my signals into this script. So I can do like signal, player, died. I didn't do the proper casing for that, but essentially I could then have, since this is globally accessible, any node in the entire game can emit player died, meaning that every other node can react to the player dying, even if there's no connection between the one emitting it and the one receiving it. And then likewise, any node can connect to this signal as soon as it's instantiated. So, for instance, if you were doing the in some of the important signals like ready, called as soon as the scene is ready, you can have it connect to that signal bus and like connect to that signal, so it can react to anytime that signal is emitted. And then some other important ones are process. This is called 60 times a second. So if you're doing any like player movement or like having to update a value, doing math on a value, that's where you'll do it. Physics process is a little different. Every time you call for physics process, it's called the same number of times. It'll just run update physics. So if you have something like physics materials and you need those to update their values, then you need to call physics process. They work very similarly, but there are a lot of people who get tripped up on what the difference is. It's just that small thing, but it makes a lot of changes that people don't realize. Input, a lot of people do, especially in beginner tutorials, they'll have if input dot, if is action pressed, then they'll list the action. I usually don't do that because I'm then checking if that action is pressed 60 times a second for every single object that has that same script. So if I'm making like a chess game and I just want to check if an object was clicked that frame and dragged, I don't want it checking 60 times a second over and over again for every single piece I have on my board. So I just do input, and then it will have an event parameter, and you can just do is if event dot is action, and then the action name, and then that's a usually more less processor intensive version of checking for inputs. And then child entered / exited. This is used a lot if you want to like disconnect signals or connect signals. So if a child enters a scene, you want to connect it to, I don't know, I think I might have an example here. Okay, I do have an example of that. So this is a very basic setup for signals. So it's just when a child enters a tree, increase the child count, and then connect it to on parent selected. And then when it exits, it just does the reverse. It disconnects it. And then anytime the function node selected is called, it will emit to every single one of the children simultaneously. So it's one line of code versus something like a for loop where I'm going for every child under this parent, call this function. So it's just a bit cleaner. And then custom signals, you just say signal, say the signal name. I did it a bit here where I just put signal. And then if you want to pass any parameters in your signal, you'll just write it like a function. So let's just say like value integer. And then you connect it. That's how you pass values through signals. I sometimes do this with if like the player can die in different ways. I'll do death type and I'll pass that for like a player died signal or something like that. And then the connect method, you'll just do whatever the signal name is. So if I wanted to, or just like here, select dot connect, and then the function that you want, or the method that you want the signal to execute when the signal is emitted. So so when node select is emitted, then it will call node dot parent on parent selected. This is generally the type how we like structure signals relative to everything else. We have it towards the top of all the methods, usually after ready and before process is where all the signals go. And then we have it as underscore on blank object blank signal, or underscore, not blanks. And then use emit to, whatever that. Yeah, so that is all. This was a very kind of hastily made slideshow, so I didn't include quite a bit. I can kind of just rattle it off. If you want to, I mean, we still have like half an hour, but some of the things I didn't include, resources. They are basically just scripts that contain data. So you could have, if you're making a tower defense game, you could have a resource for the tower's like stats. You could have its health, its attack speed, its like sprite and animations and things like that. And then you can quickly load all that data all at once. And then also when you're passing that value through signals, you're only passing one value instead of like 17 different values that you're storing inside of that a single object. That was like the last thing, but I wasn't able to make it in time, so sorry about that. Does anyone have any questions about all that I went through? I know I went through it kind of fast. So, yeah.
Do you have any recommendations for
Brackeys just started like a brand new tutorial series. It's linked under Getting Started. It's in the Getting Started section in the Godot channel. So for both 2D, 3D, he also has a video on lighting and shaders. I haven't messed around with lighting and shaders a lot in Godot. I know that Godot is pretty powerful. It's definitely not as powerful as Unreal or Unity. It was a 2D game engine first, and then they've added on better 3D rendering, but you can find videos of good 3D rendering in Godot. It's not hard to come across. So, any other questions? Or yeah.
You mentioned that it has its own scripting language and that you can use C# if you wanted to. Or is there any other languages that are supported by it?
So those are the only two officially supported languages. There are other languages like Java that I know people use in Godot, but it's not officially supported, so features are likely to roll out slower with those. So you're likely not going to have a whole lot of the features that were just added in 4.5. So you can use it, like if you want to something else, then yeah, you can. But you, like 9 times out of 10, I just say use GDSC. It was built for Godot, so it's pretty understandable and works very well with Godot. And C# if you just already know C#. So, and then any other questions? Sorry that I finished so soon. All right, well, that'll be all. In case you missed the attendance QR code, there it is. So, thank you all for coming.